Assalamualaikum and hi everyone. Today we are going to take a look at our topical question for chapter 5, Trigonometry. For the first question, we need to represent the given angles using a circular diagram, and then we need to state the basic angle where the angle is located in. So for the first example, we have theta is equal to 440 degrees. So for this example, we need to take note that we know one full rotation is equal to 360 degrees. So since we know that 440 degrees is more than 360 degrees, what we need to find is how much did we go beyond 360 degrees. So we just take 440 degrees minus 360 degrees, and that will give us 80 degrees. So now since we already have how much did we go beyond 360 degrees, we just need to draw our quadrant. So now drawing our quadrant, we just need to draw the axis first. So from here, we know that our initial side will start here. And this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then lastly is 360 degrees. If you want to calculate more than that, then what you have to do is just label here. This will be 450 degrees. I don't need to label beyond that because my angle is only 440 degrees. So now I know that my angle will stay in the first quadrant, and we just draw the line which is the terminal side for our angle, and it will be here. Now we just need to label. What do we need to label? We need to label our angle theta. So here is my theta is equal to 440 degrees, and since the question asked me to label the basic angle, I also need to label alpha here is equal to 80 degrees, which means I have a total of 440 degrees, but my basic angle or my reference angle, take note here, this is our reference angle, or we just label it as alpha, is an acute angle. So I just take the value 80 degrees as my alpha. So now let's take a look at the second example, which is question D. We are given theta in radian. Our theta is 8 over 3 pi radian. And again, what we need to do is we need to take note that one full rotation is equal to 2 pi radian. Or if you are still comfortable with degree, you can just change this into degree and we will have 360 degrees. So now for this question, what do we need to do? It's easier if we just change it to degrees. So to change to degrees, we need to use the formula theta times 180 degrees divided by pi. So our theta is 8 over 3 pi radian. I just need to substitute here 8 over 3 pi times 180 degrees divided by pi. And then I can cancel out the pi, and then 3 is equal 3 times 1 is 3, and then 3 times 60 is 180 degrees. So 8 times 60 degrees, I will get 480 degrees. So for this question, my angle is actually 480 degrees. Now again, if you take note there, our angle is more than 360 degrees. So to know how much did our angle go beyond 360 degrees, we just need to take 480 degrees minus 360 degrees, and that will give us 120 degrees. So now again, we just need to draw our quadrants. So again, as previously, this is my initial side, and then labeling all the angles. This is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And again, because my angle go beyond one full rotation, I will have 450 degrees, and then here what I will have is 540 degrees. I don't need to label any more than that because my angle stops at 480 degrees. So now I know that my angle will stay in the second quadrant. So I just need to label my terminal side there, and I can just draw the rotation. We are going to start the initial side, and then it will go beyond one full rotation and stop at my terminal side. And here my theta is 480 degrees, or you can also label this as 8 over 3 pi radian. And since I need to label my basic angle, you need to take note here, how do we find our basic angle? So alpha is 180 degrees minus 120 degrees, and that gives me 60 degrees. To change it back to radian, what I have to use is this formula, theta times pi divided by 180 degrees. So I take 60 degrees times pi divided by 180 degrees. That will give me pi over 3 radian, and I just need to label that in our diagram. Alpha is pi over 3 radian, and that is the complete solution for our question 1.